the third phase of our investigation. So I mentioned, we monitored pharmaceuticals, we did some exploration about sorption isotherms, and after that we put it on the model to calculate how they are behaving in the environment. I will not read it because we don't have time. Also, you saw this picture. This is a Belgrade water source. It has 3 water treatment plants, also 3 cubic meters per second are extracted from the groundwater. This is the study location. Also, we saw this picture earlier today. These are radial wells. This is a schematic picture of this profile. I will not pass through this. Also, colleagues did some analytical experiments. We investigated many more pharmaceuticals, but I choose only 2 to show you. Also, you saw this picture. This is radial well. This is interlayer isolation, and that is semi-permeable layer. Also, on this picture, you can see semi-permeable. So, when the pharmaceuticals go from river to the well, they are not going. Some part of them are going to this layer. Some of them are dissipating along the area. Good. Numerical method. This is also important. My colleague will present numerical method. It is new model. It is developed in Institute of Jaroslav Černi. It's WODA, Well Outline and Design Aid. It is developed by Vidović, Dotlić, Pokorni, and Dimkić. And you have free software versions on internet, so you can download it and you can use it. This is only simplified schematization. These are boundary conditions. We have Sava River, Savsko Jezero River. We have some wells. This is a investigated well RB16. We firstly collected some data about this. This is a grain size distribution. So we have 8 layers scheme. After that we step back to 3-layer scheme, and after that we calibrated the model. These are the results for the monitoring of pharmaceuticals in surface water and groundwater, and we can see some average concentration by flow. These are different time periods, and average concentration for carbamazepine is 6.15 and almost the same in groundwater, so he is evidently persistent. Also, for metamizole metabolite, he is detected in surface water, but not at all in groundwater. These are the results of calibration of model. We have 3 layers. This is first layer, second layer is semi-permeable layer, and third layer. Also, what is important, it will be presented after with Milan Dimkić and Professor Pušić. We have a hydraulic conductivity of the Sava River, Sava Lake, and this impermeable layer. And these are the basis for the calibration of the model. So if we have data about the piezometric difference between level in upper layer and third layer or down layer where the drains are, we can calibrate the model. Also, we have the data about the pumping test from 5 years continuously. This is the difference. So if this is the difference between level of groundwater in upper layer and downstream layer. So it may be boring because of 3 presentations continuously. This is the first experiment that we did with our colleagues. This is for the real sample, but this is a sorption isotherm for the sample of it's 20 grams. It was batch experiment, so we have some data about sorption coefficients. After that, we did second experiment. We have 3 fractions. Fraction less than 0.063 micrometers, between 0.63 and 1 millimeter, and more than 1 millimeter. So we have different sorption coefficients for different fractions, different size. These are the results, some of them. And after that, we have model, and we have data about this field tracer test. We also have the data about that, about the sorption coefficient. After that, we have a scheme of 3 layers, and we put these coefficients in voda, our solver. After that, we get some interesting, very interesting results. This is a tracer without sorption, without degradation. You have the time to reach the well. After that, we put first sorption coefficient for the first model, after for the second model, and finally for the third model. This is from the field experiment. You can see the sorption is the smallest, and this is for the batch experiment. And this is the experiment with 3 different fractions. So the results are significantly different. So you see the time dependence. After that, also we calculated what is the minimum degradation for the 3 cases. First model, second model, third model. We cannot quantify precisely that. That is only assumption. That is the minimal time when we can get the half of limit of detection on the well, because they are not detecting in the wells, so we can approximate it. And finally, we get the 3 models. This is with the sorption and degradation. First model, it is also batch experiment, 3 fractions, and with the field test. And you can note the difference. And what is the main point? We don't have time. When we use these sorption coefficients, and we need to quantify degradation and what is the delineation of pharmaceuticals, how they are behaving, how they are transporting to the groundwater, we need to be very, very careful which data we are using. Is this data experimental, literature, field experiments, and all other things. So we need to construct project protection zones to protect water, and we need to be very careful. And finally, this work is supported by the ministry and by the study of well aging and maintenance of the Ministry of Agriculture. Thank you for your attention. I was a little long with some technical problems, but it's all from me.